Okay, well, welcome back. And we have the pleasure of hearing from Brian Carlson, who is the Director of Global Product and Solutions Marketing at NXP Semiconductors. Brian is going to talk about how vehicle data is the lifeblood of commercial vehicle operations. So with that, I'll hand the ball over to Brian. And thank you, Brian, for taking time to present today.
Thanks, Steve. I really appreciate the introduction and actually kind of setting the stage. I'm really excited about the CVII overall because at NXP I've had focus in the vehicle networking area and gateways, the gateway to the cloud and secure communication and use of data within the vehicle for the last 5 years, and I'm leading up connected vehicle initiatives. So the CVII addresses data and services, perfectly matches to what we're doing. To put some perspective, we're the leading automotive semiconductor vendor, and we're in the center of all this because we're working with the OEMs and tier ones on their future vehicle architectures. We're working with software partners and innovators that are putting services on top, either in the vehicle for edge processing or in the cloud for providing services that take advantage of massive compute and storage. So we're kind of in the middle of all that. We see a lot, and we designed products specifically around this area to really optimize how you deal with vehicle data. And I'll talk about that in a little bit. So let me jump in. The key thing on this, why I like this topic, is because if you look at the commercial vehicle market, it is really driven by vehicle data. And I think it's a fascinating area, and it's actually, I believe, ahead of passenger vehicles. I think passenger vehicles, we're moving that ahead in next generation, but a lot of the data, as I mentioned, in commercial vehicles being used today, and it is the lifeblood of the operation. So I think it gives us some good insight into what can be done in passenger vehicles too. So I always like to start out with an overview. So I'll talk about the market very quickly, talk about the different types of data drivers, use cases, the types of data. And then what I really like to talk about is where I think it can go next, because I've been focused on this for 5 years, looking out into the future, and we know what capabilities are coming in hardware that could align really well, I believe, with CVII. So I'll talk about that and what are the future use cases around those. So I like to, as I said, kind of frame the market we're dealing with. So in the case of commercial vehicles, this is vehicles that are used for transporting goods and also for paying passengers. So you look at the range of vehicles, and this is not all inclusive. There's a lot of different shapes, sizes, weight, capabilities of these vehicles for commercial business, and they are typically categorized by their weight, light commercial vehicles, heavy trucks, and then buses and coaches. If you look at the range, even in the applications, it goes beyond the typical delivery trucks and long haul trucks, but into mining, construction, heavy equipment. All of those leverage the technology and have data that needs to be used to run their operations. So key message is it's a market that's very diverse. It is very fragmented too by manufacturers, but it is a large market overall. If you look at the amount, we're talking $1 trillion to $2 trillion sales of these types of vehicles a year. And depending on who you talk to, typically in the high single-digit range of growth. So it gives you an idea of the growth of this market. And if you look at the volume, about 83% of that market is more the low, the light commercial vehicles in the 20 million range. And I use the pre-COVID numbers because they did drop a little last year, of course, and just around the 4 million mark for the heavy commercial vehicles, and the buses are 270. They're fairly low volume. So it gives you an idea of the market opportunity and the types of vehicles. So if you look at the commercial vehicle market, 3 things really stand out that are driving the need for vehicle data. The first one is the overall fleet management. The fleet operators want to have efficient, productive use of their vehicles. They want to make the most money as they can, right, in their investment and lower their costs. So it's all about what can I do to monitor and to real time being able to be efficient with my fleet. Driver safety increasingly more important. If you look at the number of accidents in the range of 90% of accidents are human caused and could be preventable, much as the trend we see in autonomous vehicles to remove the driver, or in ADAS features as we go to L2 plus to L3, to be able to offload some of those and to make driving safer. So there's a huge emphasis on driver safety that is vehicle data driven. And then finally, data logging. That is a huge area in commercial vehicles because they have requirements for accident insights to be able to record before, during, and after accidents, complying with lots of regulations on service time and use of the vehicle. And also now we're seeing insurance. And I like the topic you guys had yesterday. I'm heavily involved in the insurance side also. So I'll step through all these just to kind of get a little bit more color on what these consist of. So in the case of fleet management, as I mentioned, it's about the operation of the fleet, safety and security, which I think will become even more important. We're seeing things like Security Operations Center, where you have real-time monitoring of the data traffic in the vehicle, and things like intrusion detection, prevention systems. This, especially, I believe, in these commercial vehicles, because the architectures are not necessarily as secure as some of the new architectures that I see coming in the passenger vehicle side. So there are, I believe, a lot of opportunities there for increased safety and security within commercial vehicles, and to be able to monitor that and to update the vehicles in real time will be very important. Location tracking is critical for many reasons, to understand where the fleet is. If there's a rogue vehicle, if there's specific terrain issues, you can route traffic over specific routes to increase efficiency, increase the range of the vehicles. You can route your traffic based on the location of your fleet. Vehicle health monitoring and the move to vehicle health management, I'll talk more about that later, is probably one of the biggest areas that uses data to be able to understand the status of the vehicle health and to be able to react and to keep the vehicles on the road, to keep the on-road time maximized for maximum efficiency. A big thing is fuel consumption and fuel economy. And that also works into terrain and routes and how the fuel is being used, whether the vehicle is being idle. A big case of a lot of fuel is wasted actually through idling in commercial vehicles. And fuel consumption can be managed real time across the fleet, and modifications can be made real time to optimize fuel consumption. That's a big area. It's about 50% of the cost of operating these vehicles is actually fuel. And then the fleet insights into the road environmental conditions and how you react to those and optimize your fleet and notify your fleet for emergency situations. So a lot goes on in that bucket, actually. The area that I see a lot of growth in, a lot of interest, is in the area of driver safety. And we're seeing this also in passenger vehicles with things like driving monitoring, DMS. If you look at, I think at least 10% of the accidents, maybe more now, is distracted driver. Fatigue, especially in these long haul applications, fatigue is really a critical area. So being able to monitor with video what's going on and to be able to capture specific use cases and to log that for later use if needed. Driver alerts. So there's a lot of information from sensors that could be used, tailgating, tire situations. There's a lot of new technologies in tires that can provide even more insights into the status of your tire beyond pressure, the potential for rollover depending on your driving, and then imminent crash. So there's a lot of information that could help alert the driver before an actual accident happens. The actual driving monitoring is very critical, because if the driver's doing risky maneuvers, hard braking, speeding, changing lanes, or making turns without turn signals, all of that's really important to help improve safety. Also drives into usage-based insurance type situations to lower those rates, which is also part of the operational efficiency, is to lower the insurance rates. Driver feedback, I think this is a really good one of coaching over time, where that driver can improve. There may be things they're doing that they're not aware of, and there could even be incentives like safe driver awards and such, and scoring that could be either competitive or motivational to be safer. And then also cabin monitoring. We're seeing this come into play, unauthorized passengers, things like geofencing alerts, if stolen trucks, et cetera. So a lot of uses for vehicle data to drive safety of that vehicle for both the driver, the fleet, and the people around those vehicles. The third area is data logging, and this is really important. A lot of this is driven by regulations. We also see the use now for usage-based insurance to be able to log that data. We're seeing more of a trend, though, to do in-vehicle algorithms to do that. I'll talk about that later, so you don't have to send as much data to the cloud for privacy reasons and for lower cost implementations. But there's also the black box or the EDR to really record what's going on in that vehicle. What's the passenger doing? What's the status of the vehicle? What were the actions taken before, during, and after an accident? That's really, really important and required by law. And the ELDs or electronic logging devices are monitoring how that vehicle is being used, the service, the hours of service, and other applications of that vehicle for regulations. As I mentioned before, safety and security anomaly detection is really important. I think that's going to become even more important as connected vehicles have a cybersecurity attack surface to be able to address those and to be able to react across the fleet and correlate across the fleet is critical. And then real-time performance monitoring of the vehicle. So there's a lot of things that need data logging, need edge processing, storage, and connectivity to the cloud to leverage all that, and to automate a lot of those processes with the government, even to make that more efficient process of how you get data to the government. And I put an example of that of how ELD works. I'm not going to work through the details here, but effectively you're synchronizing all of that vehicle traffic data that's going on, the different states of the vehicle, the engine hours, et cetera, and how that vehicle is being used and logged. And then the EDR, how that vehicle, the vehicle dynamics, what was going on at the time of the crash, what was the driver doing, et cetera, as I mentioned. So all of that's really important information that is stored within the vehicle. So everything is vehicle data driven there. So if you look at the data sources, and I've been working a lot with automated vehicles lately, and we're talking terabytes per hour of data. But in general, commercial vehicles that don't have all the autonomous, they don't have all the sensors, it's more reasonable, but it is a very diverse set of sensors from GPS localization, IMU for motion sensing, accelerometers, tire sensors. There's new types of tire sensors coming that can provide more insights into the condition of the tires, temperatures around the vehicle, all the different sensors for speed, braking, turn signals, etc. The fault codes, everyone's aware of DTCs, I think, and the fault codes, and then overall the vehicle usage, as I talked about, the state of the vehicle, the usage of the vehicle. Now, what's interesting, and I'll touch on more, is this asterisk I put at the bottom, that deeper vehicle data access will be available in future vehicles. So this is something that we're actively involved in, of going deep into the vehicle to provide access to pretty much any data, sensor, or ECU data in the vehicle, and to be able to provide local edge processing, intelligence, AI, machine learning, and cloud connectivity. So that's where the future's going, again, all data driven. I kind of put this as a bonus. I didn't have this originally in my slide. I was trying to keep it high level, but I thought it was important to look at how data is passed through the vehicle and indication of the standards used. J1939, the SAE standard, Society of Automotive Engineers, has defined, I would say, a common language of how data is passed through the vehicle. They've upgraded the speeds. They've been fairly slow. 250, still slow in my opinion, 500 kilobits per second, but for these applications it's fine. I know in commercial vehicles I'm working all the way up to gigabit Ethernet and beyond. But the move is towards 500 kilobits per second. That shows an example of the connector. This is a bus that has multiple ECUs on it that can communicate. There are definitions of the parameters and the DTCs. I mean, it's a fairly substantial, over 5,000 parameters, lots of DTCs. The good thing about this industry is it's standardized, which I really like. It's unlike the passenger vehicles that have a lot of proprietary types of things going on. These are standardized, even to the point that they swap ECUs out between one vendor and another. So there's a lot of reuse within the commercial vehicle market, which I think is really important. But on the downside of that, I see, security based on what I've seen in passenger vehicles. This is the kind of architecture that we're kind of warning against, and we're replacing in passenger vehicles because of the safety or the security considerations and potential exploits of this architecture. But it does show how it works, where there is a bus where these sit on that bus, typically at 250 going to 500 kilobits per second. There's a shared interface or a bridge between the tractor and trailer, uses the same protocol but different PHY, and those communicate. But the problem is, if one of those goes rogue or someone be able to intercept that, they can influence that. And we've seen those things happen in the passenger vehicles with the Jeep Pack and others. So concern I would have there is more on the security, but those are things that we are addressing with our hardware. So the key thing going forward, I think, is on the commercial vehicle side is the connectivity is really important for monitoring that for safety and security, as I mentioned, but also aggregating data, tracking, and enabling new services, being able to have 24/7 monitoring of vehicles, identification of issues, remote vehicle performance monitoring, location tracking for safety, and a key area that we see more and more are over-the-air updates, and that can be for new services, enhanced features, better performance, extended range, especially for electric vehicles. We're able to show how we can extend range of electric vehicles up to 30% with over-the-air upgrades over time, with new algorithms, with new information. So that's going to be really important to increase the efficiency and performance of these commercial vehicles over their lifetimes also. And I did put a quote in there from Daimler Trucks North America. Daimler is the largest truck vendor, is my understanding, in the upper range of just under 500,000 vehicles a year. So that gives you another indication too of the fragmentation out of that, the 500,000 from the leading vendor. But they show that connectivity is very critical to their operations and the services for their customers. So I thought that was important. So I really like this, showing all the types of data, the cloud, and how you can leverage that data. And what's centered there, that little gold box, is actually called the gold box. We just announced a new product yesterday, the S32G2. It's a vehicle network processor, and it's totally aligned with CVII, with this architecture, with these use cases. It's all about data and services. It is service oriented. It really is the future where passenger vehicles are going now to a more of a centralized vehicle computer that's dedicated to data, security, and safety. And these service-oriented gateways do provide vehicle services that can map across the vehicle, have vehicle-wide access to data, and provide that centralized access. So it actually is very an ideal place to do a lot of this aggregation for filtering, doing machine learning, and it's something that I think is going to really enable a lot of these new capabilities going forward. So just to show how that works, we're doing a lot of work now with cloud service providers to provide end-to-end. So that gold box has a very substantial processor between microcontrollers and microprocessors, vehicle network accelerators, built-in safety and security capabilities up to ASIL D. It provides a substantial amount of capability to do these things. So on the vehicle edge, you're doing all the initial data capture, you're aggregating data, you're filtering it, you're doing machine inferencing, you're reducing the amount of data, both for making that transmission economical for privacy reasons. You're securely transmitting that to the cloud, and in the cloud it ingests it, processes it, does machine learning training. It can do digital twin models. It can do the storage and then tie it to the back end into the business intelligence, the whole enterprise with manufacturing, design, supply chain, and really tie into vehicle prognostics, vehicle health to optimize the supply chain for parts too. Now, one thing I do note here is that those functions of the event data recorder and the electronic logging device are really interesting. We're already seeing the trend in the passenger vehicle space where this type of processor is taking on data logging functions. So we're seeing a lot of that. It has the capability with PCI Express to support automotive grade SSDs and terabytes of data within the vehicle. So it's really an exciting time. This is a new type of product. We talk about it's a new type of automotive processor that's really focused on data and services. So totally aligned with CVII and the use cases both in passenger and commercial vehicles. If we look ahead, this is what I'm really excited about. We're already showing this in action where a connected vehicle can take that data that's processed on the edge and it can drive improvements over time. And it's really going to be key for success in autonomy and electric vehicles. So we're showing how you can capture data, process it locally, with substantial processing performance, machine learning, anomaly detection, data reduction, bringing that data up to the cloud to be processed to train machine learning models, to deploy those models back to the vehicle. Some vehicles have over 40 machine learning models, so you can actually improve the vehicle over time, so it gets better, so that fleet can get better over time. It can also be used to improve safety, security, et cetera. But this is going to be really key as this whole data management lifecycle with machine learning. And we just showed this recently. We're part of what's called the Fusion Project, which brings this whole end-to-end with 4 other industry companies. So the Fusion Project is providing kind of an end-to-end solution to do this. That one's based on Cloudera, which can go on any cloud platform. So looking ahead, I think this is where I'm really excited because we're already working in this area with a lot of service providers, cloud providers, OEMs, and tier ones, and I think in the commercial vehicle can benefit from this. But upgradable vehicles becomes really important. How do I update new services, provide enhanced features? As we look in design optimization with digital twins, you can get real-time data of the vehicles running and run those in actual digital twin models in the cloud. You can learn from that to understand performance. You can download new capabilities to the vehicle in the background to understand and look at that ahead of time before being deployed to the whole fleet of vehicles. Machine learning, as I mentioned, to optimize the performance efficiency of the vehicle is going to be a really key area, all data driven. Predictive maintenance, we talked about monitoring vehicle data for vehicle health, but this is going to take it to the next level, working with companies that are doing artificial intelligence to be able to really look at the component aging process to understand when a component's going to fail before it fails, before the check engine light comes on, and to be able to tie that into the supply chain and optimize that and to keep the vehicles on the road. And then finally, advanced insurance services, very heavily involved in insurance. When you take a platform like this, you can do some really amazing new advanced insurance services right in the vehicle that you can't do typically today on a lot of the platforms because they don't have the performance, they don't have the data offload. So now you're able to do insurance things like with electric vehicles, with cybersecurity risk assessment. There's a lot of things you can do with data in the vehicle. So the key here is going to be having a common way to get data. And I always talk about we need to move from raw data to information, right? We need standardization. So CVI is perfect for that. And evolving this fleet is going to be through big data, AI, connectivity, and standardization. So overall, hopefully that came through that commercial vehicles, I think they're in a very prime position for all these things we're talking about with data and services. There's lots of data available. It can be used to make the fleet more efficient, safer, and be able to provide deeper capabilities with artificial intelligence, enabling with these service-oriented gateways and being able to improve these commercial vehicles over time with vehicle data. So hopefully that was good insight into what's happening, where it's going, and what the capabilities are. And again, excited about CVII and how that mates into what we're doing too. Thank you.